So, looks like the first 3 lectures killed a good 30% of the audience. So, from now on, there will be no more lectures without languages. So, I put all the boring stuff at the beginning. From now on, we talk about Matlab, Mathematica, C. Maybe I will spend 1 lecture about performance, but that's about it. So from now on, you will see me at the laptop a whole lot, and we will do some programming. Today we start with Matlab. So I start off with just a couple of slides of introduction, and then we move on to the actual prompt. Matlab was created in 1978 by Clive Moller. Clive Moller is a numerical analyst. Back then he was at the University of New Mexico, and he was using the standard Fortran libraries to teach numerical linear algebra. He wanted to help his students. These libraries, ISPEC, LINPEC, were written in Fortran. So he wanted to help his students, and so instead of having them coding in Fortran, he decided to write an interface, which is classic Matlab, to interact with numerical linear algebra objects without having to actually code them in Fortran. So he introduced the concept of vector, he introduced the concept of matrix, and he offered the possibility of multiplying vectors with matrices by themselves, with one another, without actually coding them, simply by writing A times B. So this was Matlab. He had routines to compute the eigenvalues and eigenvectors to solve linear systems without actually getting at the Fortran level, invoking the libraries, simply just saying eig of this or that. Okay, and that was the classic Matlab. And it was purely for pedagogical purposes, so for teaching. It was only 6 years later when somebody in the audience realized that in the audience he was presenting this tool, and somebody in Stanford realized that this object had a lot of potential, commercial potential. And the guys teamed up and decided, okay, why don't we rewrite this? This time let's rewrite the whole Matlab in C, because C was more flexible to build an actual system than Fortran. Remember, back then Fortran didn't have recursion, didn't have a dynamic allocation of memory, so C was way more flexible. And I created Matlab 1. And here is a brief history of the Matlab versions. So colors came up in '87. Sparse matrices and a debugger came up in '92. Object-oriented programming, '97. Multidimensional arrays, so I mean beyond matrices. Matrices were in since the very beginning. Something more modern, the desktop field, the graphical interface, they came up in 2000, and actually in 2000 really things changed. Matlab took a serious departure from before, with the introduction of BLAS and LAPACK and RPAC directly under the cover. So what does that mean? Until 2000, Matlab was implementing its own matrix-matrix multiplication. It was implementing its own solution of linear systems and computation of eigen solvers. But they realized, they tried to keep up with the fastest BLAS, so matrix-matrix multiplications and linear systems and eigen problems solvers. They tried to keep up with them, and in 2000 they finally realized, you know what, these libraries exist. They are optimized already out there, so why should we compete with them? And so nowadays, when you multiply two matrices in Matlab, that's nothing else than a wrapper to BLAS. So that's a call to BLAS. When you solve a linear system, if it's dense, if it's sparse, it's a completely different story. But if it's dense, it's nothing more than a call to a LAPACK. And this really boosted Matlab's performance. 2002, they spent more time, they spent more effort in improving performance with version 6.5. Starting from 2004, we had even non-double arithmetic. Until then, it was all double arithmetic. Pure functions, so this is going more towards what Mathematica was doing. As time passes by, MATLAB tried to conquer more and more territory, so it would cover more and more of what Maple and Mathematica are good at, and vice versa, of course. So nowadays there is a package for symbolic computations. Well, not nowadays, it's been there for quite a while. But of course, MATLAB is nowhere near as good in symbolic computation as Maple or Mathematica are. So starting from 2005, there are a couple of releases every year. Every 6 months, there is a new release. So new bug fixes, a few extra features, but nothing major has happened in the past 5 or 6 years. Down here, I listed some projects related to MATLAB. Some of them are MATLAB, parallel MATLAB. This was presented already, I think, six or 7 years ago. Nowadays, has caught on a bit, but it's still nothing comparable to what MPI, for instance, would accomplish. So MATLAB is still an environment for prototyping, and parallel MATLAB allows you to, prototype on a parallel scale, but don't think that this is high-performance computing or high-end computing. So pMATLAB is more or less the same thing. Star P used to be a project parallel to MATLAB, built on top of MATLAB. This has been acquired by Microsoft. I don't know if it's still supported. Normally, they don't do that. Octave is the open source replacement of MATLAB. It's actually a very good project, well-supported project. It tries to mimic MATLAB as much as possible in syntax, in functionalities, but it's open source. So maybe it's not as optimized, as powerful, but if you don't want to pay, that's the way to go. All right, that was for the history of MATLAB. Just a couple of references. There are a couple of books. They are pretty nice and pretty easy to follow. Both of them are published by SIAM, and do not underestimate the online documentations, so help and doc. These are really priceless tools. They are, especially doc, it's really well made. Okay, now I will switch to my prompt. These are the constructs that the statements, more or less, that we will explore today. I don't know if I will cover all of them, but so this is just for your memory. And if I remember, I will run diary, which will record. Oh, actually, I don't need to do that because we have the video. Okay, a diary is an instruction. Once you execute it, it records all of the strokes, so everything that you typed, all the inputs, and also all the outputs, and stores everything on a file. But I guess I don't need to do that. So enough for this. Let's go to MATLAB. Okay, Matlab is interpreted, so in order to execute anything, you need the interpreter. Even if you have your files, you cannot do anything without an interpreter. This takes a little bit. I can introduce you already the file names. So the files to be executed in Matlab have to have a .m extension. They are also called M scripts. Functions in Matlab, if you want to define a function, that needs to be stored onto a file. The file and the function name have to be the same. Okay, so this is the interface, that's the prompt. If you want to do something, you can interact with the prompt directly. For instance, ls tells me where I am. For instance, edit invokes an internal editor. It opens the internal editor. You don't have to use this. I love Emacs, so for instance, I would I would edit my scripts in Emacs. What is important is that whenever you do something, you save the file with a .m extension. So let me show you something. This is works classes. Okay, so this is my directory where I have some M files, you see, bad.lu, py, and so on. Some of them are functions, so a function I cannot execute. Some of them are scripts. Scripts means they're a sequence of instructions, so I can invoke them. I can execute, of course, I can open Matlab, and from the Matlab environment, I can call these scripts. So let me show you. I can do that. I'm here. I do. Okay. So I could execute py. In this case, py call. Ouch. Ha. bad idea. So py. We call it script. We rename it. No. Yes, thank you. Not that. This is better. Okay. So, script. Answer 0. Okay, why? Maybe I should show you what is in script. Okay, in script I am comparing two numbers. I start from pi. In Matlab, pi is constant, so these stores 3.14, 27, whatever. Then I add 10 over 3. I don't know if you can see it, but it's divided by 3. Then I subtract 10 divided by 3, and then I ask double equal if the result is actually equal to pi. So I expect a Boolean answer. Okay, and from what you have seen before, I executed script, and the answer is 0. So adding 10 over 3 to pi, subtracting 10 over 3, and then comparing to pi, I don't get an equality. The answer is 0. Now, let's do the following. Let's try to add 1.3. No, that's going to be the same. 0.3, yes, 0.3. Okay, so I have another Matlab script. And now I execute it like this, maybe like this, Matlab. And as input, I pass script. So this is Unix, Linux. It means pass the contents of these files to Matlab as input. You don't have to learn this. I'm just showing you. So I have passed the script to Matlab. Matlab executed it. I'm not inside the Matlab. I just see the output. The output is 1. So now those two numbers are the same. I can also do cat script and pipe it to Matlab. Same result, okay? So cat reads the contents of a file, pipe passes it to the next instruction, to the next program. In this case, it's Matlab. So Matlab has an M file, executes it, spits out the result, and exits. Anyway, okay, this is just to show you how to use M scripts, but most of the times you will actually live inside of the Matlab environment. Now we are actually inside. We are running Matlab, and we can invoke scripts directly from the interpreter. Okay, so I showed you, oh, this is the editor. We don't need the editor right now. This is the interpreter. Okay, what we can see, pwd, same as in the Unix, gives you the working directory, cd, change directory, ld list, and I showed you edit already. Okay, what, you have the arrows, so you have an history. You can also have a completion, so if I type L and I move upwards, it automatically goes to all the previous instructions that start with L. This is useful when you have lots of instructions. You remember maybe the prefix, and you can just circle through them. Okay. Briefly about the syntax of Matlab. Matlab uses commas and semicolons to connect instructions, commands. So I can say pi, no, a equals pi, equals, that's the assignment, and you see that is different from the double equal. We have seen the double equal before. Double equal is a comparison. Okay, I can say then b equals 2 times pi. And each instruction spits out the output. So a equals pi, and I get a equals pi. B equals 2 times pi, okay, b equals 2 times pi. That's with the comma. If I use the semicolon, c equals 3 times pi. Semicolon, do you guys want me to do this? Should I do this? Is it better? Yeah, okay. If I use the semicolon, this thing inhibits the output. So in this particular case, I still have a sequence of instructions, but only the first one gives me an output because the semicolon inhibits the output. It doesn't show. Still, if you look, C is 3 times pi, so the instruction has been executed, it's just that the output has not been visualized. So semicolon is pretty good when you have some instruction that spits out a lot of data. You put a semicolon and the computation still goes through, but you don't have the output. Yes?
So if you would replace the last semicolon with a comma, it would give A and C.
Yeah, in that case, I don't even need to put a comma here. If I put a comma, it means that here there is even something more. You can just leave it empty, and it gives me A and C. Yes? By the way, please ask me questions. Most of the times I will not know the answer, but that's okay. Okay, so we have colons and semicolons. Then we have a parentheses and a square brackets. Parentheses are for arithmetics, so they give precedence to operators. That's exactly how you would do, how you would use them. Ta-da. And also Parentheses are used to call a function, sine of pi. Notice that it's not 0, that's interesting. And they are used to access an array, a vector. And I'll show you that in a minute. Square brackets are used to define a vector. So square brackets are super important. These are constructors, okay? If you construct something like this, so you are actually constructing nothing, but nothing is perfectly well defined in Matlab, so that's the empty set. It's a 0 by 0 matrix, okay? Matlab is perfectly fine dealing with zero-dimensional objects. Okay, so maybe before getting into more programming, let me say that if you use the graphical interface, this thing offers you a lot of tools that I will not cover in the list. So it has a debugger. It has the possibility of visualizing a lot of information, for instance, the directory. How do I show the directory now? Maybe here. Edit file. So command history, okay, this is easy. It's whatever we have typed so far. Then current directory, that's what I meant. And here there is the contents of your directory, files, scripts, so you know what to call, what to invoke. Okay, let's kill this. Then we have a workspace. This is pretty useful. It shows you the active variables in the current environment. So far we have not defined arrays, so everything that we have is size 1 by 1. Notice how scalars are actually seen as 1 by 1 matrices, okay? And even what we just created here, the empty matrix, is seen as a 0 by 0 matrix. Okay, workspace. Workspace is pretty useful. And by the way, you can customize it. You can even show the contents of the variables. You can show the contents of the beginning of an array. You can do a lot of things here. You can show the type. Then there is a profiler, debugger, and help. So help over here, this is the helper. You can get here through the doc function. Doc. So there are two help systems, as I said already, help, and help of help is the way to go. And it explains how to use help, or if you just type help, it gives you, fortunately now we have lots of packages, but if you go to the top, here we go. You see that the instructions and the functions are classified by type. So if you're interested in the syntax, probably you want the ops. And it explains what kind of operators are available in Matlab. So now you can just do help punct for punctuation, and you will get all of these things, help of colon, help of less than, LT, and so on. So help very important, and doc even more important. Okay. So constants, as I said, pi is a constant. It's not a symbol. When we will go to Mathematica, we will see that these two things are completely different meaning. Pi in Matlab is just a shortcut for a long number. It's not a concept. You cannot ask Matlab for the first 50 digits of pi. It doesn't know them, okay? It's just a constant, and it's called pi. Now look at something truly horrible. Watch this. Pi equals 3. I think that pi it's not 314, it's actually 3.0. What do you think it happens? It does. No complaints. It goes through, and from now on, our pi is 3. Okay? Be careful with these things. MATLAB, unfortunately, doesn't have protected symbols, so you can redefine constants. Who's let you inspect the workspace, and it doesn't say, it doesn't show the value. Let me see.
So you can reassign values to constants. There's a difference between constants and variables.
There isn't, unfortunately. You can clear pi. So I removed it from the workspace. It's not a variable of mine anymore. And now it's back to 3, 14, 16, and so on. By the way, if you're not happy with these five digits, then we just have to go for a longer format. And now these are all the digits of pi that MATLAB knows. And if you want to see how format works, since there are plenty of different formats is pretty useful, and here it shows which formats you can use, okay? Do you guys know about this? Yeah? What should it be? I heard an I. So it's the square root of -1. It's the imaginary number, of course, the imaginary unit. That is associated with I. So you see, I is another constant. It's the imaginary unit. Actually, it's the same as J. Do you know why J is the imaginary unit? Can anyone come up with the reason? Why would J be square root of -1? That's a good answer.
I think it has something to do with the face.
No, it's more programming. Yeah?
The electrical engineers use I for current.
Okay, that's...
They get very foxed if you say I for the imaginary number.
Precisely. Every programmer will use I as an iterator. Immediately, I'm not going to jump to the 4 yet, but you will have I that goes from 1 to whatever. And following this instruction, I is not the square root of -1 anymore, but it's an integer. So be super careful with these things, okay? That's why there is also J.
So if you have a 2-level loop?
Yeah, you have lost the square root of -1. That's exactly the point. Okay.
So if you assign something to I, what will you get for the square root of -1?
Those are different i's. So this is this is just formatting. But let me show you. So I is a 6. Okay. So that's just formatting. It's a different story. Okay, so I told you that there are some constants. Once again, those are not symbols. What I mean by that, letter A has been defined, okay. Letter D has not been defined, so I cannot do A plus D. I cannot do that because MATLAB doesn't know D. A plus pi, sure, that is no problem. Okay, the symbol D is undefined. MATLAB cannot do anything with it. So this is not a symbolic environment, at least unless you include the symbolic package. As I said, these guys build arrays, so let's get into that. Okay, what do you think is happening here? I am concatenating 3 elements, and then I forgot to put commas. So what do you think is going to happen? It's no problem. Actually, commas or no commas are the same. Commas, it's just a syntactic sugar. When you build an array, you don't need commas, okay? And by the way, Matlab was born, clearly you've seen that everything is stored as a matrix. So it has a really strong understanding of linear algebra. So this is a row vector, completely different with respect to a column vector. How can I define a column vector? Well, now the semicolon is actually needed, is necessary. Okay, by mistake I left one empty entry. Let's see what happens. It's no problem, it's just it just skipped that entry. It means it's empty, so it didn't even include it. But it didn't complain at all. And you see how it even plots it as a column. So it realizes the difference between a row and a column vector. Let me show you. This is V equals, and this is W equal. And now if we go in whose again gives you the environment. Now V it's a 1 by 6 and W it's 5 by 1. So 1 is a column, 1 is a row. And if I combine columns and rows, I get to a matrix. So far I am defining a row, but now I put a semicolon. This means go to the next row. And now I can define the second row. The result is a matrix, is a 2 by 3 matrix. Notice once again, columns are there, are not there, doesn't matter. Semicolons, very important. How do you transpose this object? With the apostrophe, with that thingy up there. That transposes an object. Yes?
What happens if you concatenate two row vectors of different length?
No, that is not allowed. Unfortunately, these are matrices and they are really matrices. So you cannot attach objects that would not shape up in a matrix. I don't want to say that they have to have the same length and width, because that is not true. They just have to combine together into what is a matrix. Let me give you an example. So let's say that A is 1, 2, 3, 4. This is a 2 by 2 matrix. B equals 1, 2. No, let's say 5, 6. Okay, this is a 1 by 2 matrix. So far so good, right? So can I combine A with B transpose? Yes or no? Yes. People say yes. So this is a 2 by 2 matrix, and this is a 1 by 2, but I transpose it, so it becomes a 2 by 1. So I'm trying to put together A with the transpose of this object. Notice that these two guys have not the same size. They have the same number of columns, yes. The same number of rows, yes, but they do not have the same number of columns. Still, I can put them together. This is no problem. And the result is a matrix. Now, what would happen if I did this? Now I'm actually trying to attach these guys together without the transposition. Can I do that? No. And let's see if Matlab complains. And it does. It says that the arguments of cat is concatenation, are not consistent. So you cannot attach entries that do not shape up into a matrix. Yes?
But there should be something like a vertical. Can we add it to the
Oh yeah, absolutely.
row to the thing?
So let's try. I like these questions. If I can erase. So now the question is how to clean the board. That is the question. So can I attach something down here? How to do that? And you guys can answer already. Yes, I have an answer.
With a semicolon between A and B.
What did you say?
With a semicolon between
Ah,
A and B.
okay. With the semicolon. So A, I place it there. Semicolon goes to the next one. As long as the operation is well defined in terms of matrix shape, everything is fine. Okay.
What if you now add a vector with 3 rows?
So what if now I add a vector of 3 rows? Okay. So how would I do that? He wants to attach a column with 3 rows. He wants to do this. So how to do that? Yes, you are allowed to do that. So how about okay, what am I doing? Here I just did it. I'm building this object. Notice that I didn't place a semicolon, so this is like a column. So I'm going to the next column. What is the next column? Is a 1 by 3. I just defined it. So let's see if it works. Works perfectly. These square brackets in Matlab are very powerful, okay? This is one of the strengths of Matlab, manipulating matrices, or tables for that matter. Okay, one last example. Can I do this? Can I do that? It lets us do it because everything in terms of matrix sizes makes sense. If we do that in Mathematica, we get something completely different because Mathematica keeps track of the nesting. But here, everything is fine. Everything is converted into matrix format, and so all of that makes sense. Yes?
So, is there any difference in the way Matlab stores this in the memory? Like if we write just 1, 3, 4, 5.
No, there is no difference. Yeah. Everything is flattened, and it's not like in Python. In Python, there would be differences. No, this is flattened, and everything is all the same. Yeah. Okay, you can play with size. Size is a function that takes an array, a multi-dimensional array, any array, and gives you the dimensions. Size of this thing. In the end, it's just a 3 by 3 object. Size 3 by 3.
Can you set that?
Can I set?
The size?
No, I don't think so. So how to create more involved or more useful arrays? After all, it's not very convenient to actually type entry by entry. Well, the for loop, I will explain it later, but there are a number of different ways of building arrays. Let's start from zeros. After all, everybody wants to build a zero matrix. So 0, 3 times 4, sorry, 0, 3, comma 4, it's a 3 by 4 matrix, which contains only zeros. If I remember correctly, this is a 4 by 4 matrix. Yes. Since there are zeros, there are also ones. Here we go. And if we want a column, so if we want a vector, we just have to put a 1. This is a row vector. This is a column vector. Okay? Probably the most useful one is random. So once again, random 4 is a 4 by 4 random matrix. And if you want a random number, you just go for 1. If you want 10 random numbers, be careful. You don't want to do this, but you want that. Okay? Yes?
Probably a stupid question, but can we also leave the commas out in function calls?
No, you cannot. Yeah. Okay.
Can we put parentheses?
Can you put?
Put square brackets around, so we give the vector one.
Yes, there are some, I'll get into that later, but there are functions that do different things depending on the type of the argument. So you can put square brackets sometimes, so you can pass a list, and the function sometimes is mapped, so it's applied to each entry of the list. I will show you this, I don't know if today or the next time. So rand, and by the way, if you are into randomness, rand and rand n are completely different. Random generates uniformly distributed variables between 0 and 1. Random n is a Gaussian, is a normal distribution. If you want to know more, help rand n, and it explains exactly what I just said. Here we go. It's normal distribution. Yes. Okay, more.
How do we get integer when
I think that the best way to do that is to floor. So if you have a range, you just put the range and you floor, and that's going to be a random number between 0 and 9. Or if you don't like floor, you go for ceiling, which is the I don't know if it's a ceil or ceiling.
wild guess, but what about rand I? That was at the end of the help for rand.
Okay, I was gonna say. By the way, this is how I do it. I don't know if it's if there is more. So rand I integer values. Here we go. So. By the way, I'm not trying to teach you what Matlab does, so forget about that. I'm trying to teach you how to program in Matlab. I only know probably 1% of Matlab's functionalities, Matlab's functions, but I can program in Matlab, so I'm happy enough. How to generate things? Okay, so together with the square brackets, probably the single most important concept in Matlab is column. This is the most important thing in Matlab. Okay, what does that do? It generates a sequence of numbers between 1 and 10. If you don't specify anything, it goes in steps of 1. So that thing over there goes from 1 to 10. And this goes from 3 to 10. And if I put a real number, it still goes in steps of 1. And if I put a real number here, okay, now it starts from the left interval, from the left number, and it keeps adding 1 until it doesn't pass the right margin. Why is this thing so powerful? Well, for instance, you can go in steps of 2. Okay? And for that matter, you can go backwards. All right? And none of these things need to be integers, okay? You can go in steps of pi, and so on and so forth. So now we can create, now we have a question.
So the result is again in the matrix.
Precisely. The result, you see, it shows columns 1 through 4, so it shows the first 4 columns, and then columns 5 through 7. So what it's doing, it's generating an array, a linear vector. It's just that it doesn't fit here, so it shows first 4 and then next 3 columns. If we go for format short, here we go, we see it more clearly. And if we assign this, then we look at, it says it's a vector 1 by 7. Okay, you can of course do this. And now V, it's going to be a what? Haha, okay, I see. Yeah, and now it's a column. Finally, we have linspace. That's what you would do to figure out what linspace does, but I will just tell you. So, linspace, how does it work? I think it takes... so it takes a left and a right boundaries, values, and it splits the interval into how many, actually, it creates 3 ticks. So in this case, it splits it in 3 minus 1 intervals, okay? Which is kind of counterintuitive. You would expect 3 to have 3 intervals. Well, you have to think in terms of how many numbers to put in this interval instead. So if you only put 2 numbers, okay, and if you want, that creates a vector with 100, well, with the 98 numbers in between 1 and 10. Okay. So all of these are instructions, are ways of building vectors or matrices. We can go even to higher dimensions. This is a 3-dimensional object. I have created a random object size 2 times 3 times 4. This must be the worst eraser in all RVT, huh? So we have 2 times 3, and then we have 4 slices. Okay, and how does it plot this? It plots this by slice. So you see that over here it's showing whatever, comma 1, which is the first slice, whatever, comma 2, which is the second slice. So it's showing me the first face, that's the top one, then it shows the second face, and so on. Slice, and so on. You can go to higher degrees, but all of these slices have to have the same size. After all, it's nothing more than a higher dimensional matrix. So somebody calls it a tensor. It's really not a tensor in mathematical or in physical terms. It's a tensor in computer science terms. Anyway, it doesn't matter. What it matters is that you can deal with higher dimensional objects. If you really, really want to put together objects of different sizes, you can do that. You would use the cell instruction. I recommend you guys think twice before putting together objects that are not of the same shape. Most likely you are not doing the thing you want to do, but so in case that's what you really want, cell is the instruction to use, the command to use. And with cell, the curly braces come along. I don't want to talk about this because we will really not use them, but in case you guys need them, be aware of cell and curly braces, okay? So I was talking about the semicolon. Yeah, right. Colon. Why is it so important? Did we define something? Let's define a matrix. I think I have a matrix. Okay. See, let's define should this work? What did we define B to be? I think it, nobody remembers. I think it's 1 by 2. So if it's about 1 by 2, will this work?
Yes. Yes.
And what will be the dimension of the final object?
No, it won't work. We need 6 pieces.
So let's see.
3 times 6?
I like 3 times 6. So A should be 2 by 2. And B, if I remember correctly, I might be wrong, but B, I think it was 1 by 2. Then what we are doing, we are putting 3 A's one next to another, so it's 2 times 6. And then we're just adding 1 times 2 for 3 times. So it might be that is 3 times 6. Yes?
How does this evaluate the instruction? So I can look
What?
at this as A. Okay, wonderful.
Say.
No, so we can think of this as A, then, I mean, A, then another A after that, then the A, B thingy after that or something.
No.
Sequential kind of evaluation or something.
Remember that it would be like this. Read it from left to right until you find a semicolon. Semicolon means go to the next row. Okay? In a way, it's the matrix is stored by rows if you want. Read this row by row. Okay, now let's go to the column. So I told you that parentheses are used to access entries of a vector of a matrix. So 2 by 2, 2 comma 2. This accesses the second entry of the second entry of the second rows or the second entry of the second column. So which number is this? It's 4. Okay. What if I want to access a full row or a full column? Well, I use the column. This one, it's like a wild card, and it tells me, okay, this is the second row. It's a matrix notation. Which second row, which column? It's a wild card. It means every column. So we are extracting the second row all at once. Yes?
If you only want to have the ones with odd columns.
Say it again. What if I?
The odd columns.
Odd columns. Okay.
When you just
So,
get the sequence in this, or
absolutely. So only the odd columns. One is the left margin, 2 is the step, 3 and it's the right margin. Since I don't know the size, I have that shortcut, and. So these guys here, let's look at what we have. We extracted from the second row only the odd entries. Does anybody, well, is everybody in agreement with that? Is happy with that? Okay. We can do more. What is this? The first 2 columns? That's not the right answer. Remember, I look C of 2, first entry, I fix the row, and then 1 and 2, now I fix the column. So I'm marching through the first 2 entries of the second row, which are 3 and 4.
what happens if you use non-integer numbers?
Doesn't like it at all. let's continue with this. So how about, let's take an easy example. So we have b. Now b of -1. Well, first of all, what is b of 1? It's a 5, yes. It's not so obvious that it's a 5, but, well, maybe it is. So,
What is 1 of b transpose?
1 second. What is this then? C of 2. We're getting the Matlab bingo. Actually, what this is the second entry of the first column. And from this is not too clear what's happening. Maybe this gives it away. Can anyone guess what this is? It is a 2. So the matrices are stored, even though we input them by rows, they are actually stored by columns. And if you invoke, if you access a matrix with only one entry, you just march through it by columns. What is this? No. Yes. Can you read what actually? Precisely, yes. It is the whole matrix read entry by entry, but also column by column, because I told you that's how things are stored. Okay?
So you know the answer is a column vector.
Yes.
You can use it as a column vector.
Yeah, absolutely. It is a column vector. Okay, all of this was because I was asking you, how about this? Too bad, MATLAB doesn't like it. This will work in Mathematica, it doesn't work in MATLAB. So if you want B, or if you really want 6, you do. Okay? So AND automatically knows what's the end, and you can go backwards from AND to the beginning. So now you can do. Okay? Yes?
Can you specify which entries you don't want to add?
Which?
Like
Yeah, of course. Sure, why not? But, so you have seen that already. When we have asked only for the odd ones, we did specify a filter. What did we do? We actually generated a list. So let's say that we want, what do we want? We want, what am I asking so far? Yes, a whole column. I have not specified which column yet, but I'm asking for a full column. And now you say, can we put a filter? Okay, maybe I want only this column. So what am I asking here? Is this a stupid request? Is it? Yeah?
You take the second column and the third column, and then again second, and add them together.
Yeah, absolutely. This is a perfectly valid request. I access the second column, then the third, and then I access the second, and I put them together. All but the first column.
So there's something like not one. Yeah, of course.
You can play with it. Let's see if I have some smarter examples. Yes, I definitely have smarter examples. What is this?
2 by 2 matrix.
Yes, it is a 2 by 2 matrix. What does it contain? Yes. This is the leading 2 by 2 submatrix. So it's the top left corner of the matrix C. So it's 1, 2, 3, 4. Now, let's write something else. Wait. I'm trying to make it more interesting. Okay, how about this? Yes.
I just had a question. Does Matlab have set operations?
What operation?
Set operations.
Set operation. Ouch. I'm not prepared for that.
Okay.
I would have to look it up. I don't know. I know the set operations in Mathematica I never used, because really you cannot use the symbols. So sets, I'm not sure. I never used the sets in Matlab, I have to admit. What is this?
A 2 by 2 matrix with the columns 5, 3, and 6.
1 second. Tell me again.
A 2 by 2
Yeah.
matrix.
Yeah.
The columns 5, 3, and 6, 4.
Okay, is that correct? So I take that. Everybody agrees with that? Any other opinion? Yes.
I would say it's left side 4, 6, and right side 3, 5.
That way. Say it again. Left side is what?
4, 6,
4,
and 3, 5.
3, 5. 4, 6, 3, 5. I like this. Any other take? There are only how many permutations are there? It's 4 factorial. It's not too many, right? It's what? 24. How many vote for the first one? Yeah. How many for the second one? Oh, okay. So you don't express your opinion. Okay, why would it be the second one? So we are marching through the rows in order. So we take the end minus 1 row first and then the end row. So we know that we are second and third row. Okay, now what do we have in the columns word? We start from the end, so from the last column, and then we march backwards to end minus 1. So what do we have? 4, 6, yes. And then we march backwards, 3, 5, yes. So I also vote for number 2. And it is, yeah. Questions? No. Oh, you guys are having a sauna over there? So, okay, one more and then we go into something more complicated. What is this? Even the formatting is disturbing, but let's live with it. What is this? So let's start easy. What is the dimension, the size of the resulting object? Yeah? It's one vector. How long is the vector? Why would be a vector, though?
I think it's a 3 by 6 matrix.
Somebody says 3 by 6. Anyone, any other opinion? I think it is a 3 by 6 matrix. So what are we doing? Over here we work on the rows, and clearly we are extracting 3 rows. Okay, we are accessing the matrix at 3 rows. What portion of the row? The whole row. So it's going to be the first row followed by the second row followed by the second row. So it's a 3 by 6, and you see the second and the third row are the same. Okay. So this is C. Now,
How do you make a Boolean vector?
Boolean vector. So maybe I want to say C less than 3. This thing here creates an array which has the same size as C, but contains zeros and ones. Zeros are false and ones are truth. So over here, I get a matrix that tells me which entries are less than 3. 1 second, 1 second. Let me store this object. Now, use the, here we go. All of a sudden, we have Boolean variables. Yes?
Can I do something like C, open parent, D, close parent?
1 second.
Can you use it as an index?
C what?
Can you use C
As the index.
and D?
Yeah, you can do that, I think.
Okay.
Yeah. And this is actually the really cool part of it. But I have to point out, for those of you who are in computer science, how many of you are from computer science? Not so many. Okay. Yeah?
Why does it need 18 bytes to storage?
Why does it need 18 bytes? Man, these questions are difficult. 3 times 6, so that's easy, come on. 18.
Maybe you only need one bit to store logic.
Yeah, I know, but wait a second. That's what I was getting to. I don't know why it takes a byte, but wait a second. So let's take D1.1, comma 3. What is this? This is a 1, okay? Let's add the pi to it. So actually, let's do the following. Okay, I just added pi to this entry. 1, 3, no pi. What happened to, oh, didn't like that? 3. Where? You think it's so easy? Wait. Okay, so let's try something else. K equals that. Okay. Okay, so I built the horror story. It's not as bad as I thought it was, but we took a logical number, we added a 3, and all of a sudden we have a double. Okay? So that is a logical, it's a Boolean, but really it's just a number. So you can extract it and use it. And at that point, this is not a logic number anymore. Yes?
So can you apply all the elementary operations to make this?
Not really, but you have the dot so that you apply, so for instance, 2 times m, it wasn't m, it was d, okay. And if you have c times d, that would not be defined because that's a matrix multiplication, but this is defined. And it's a 1 by the point-wise, it's called Hadamard product, entry by entry product. Okay, is that the question? Yeah.
Can you fill a matrix with characters or
strings? I never tried that. Yes, you can. I clearly knew that.
So what if you had your own? So 2, 1.
Well, that's. I think it's perfectly fine. Now the question is, would this work? Then this should not work. Yeah. Wow. Okay. Okay, I'm learning Matlab here. Let's move on. We're really not going super fast. I want to show you something more brutal.
Is it then just a 2 cross 1 vector?
It's, I think it's a,
It's not a matrix anymore.
I think it's a 2 by 4. Ah, I hate this. 1 second, 1 second. I'll get there. It is a 2 by 4. Yeah.
Can you go up? There was this C star D and C dot star D thing.
Yeah.
Yeah, so C dot star D is basically just an element by element multiplication?
Precisely. I will show all of these later.
So
Yeah.
C star D shouldn't work anyway, right?
C star
Because
C.
C is a 3 by 6 and D is 3 by 6, they can't be multiplied.
Absolutely, no.
But you can do a normal matrix multiply, so C transpose D or whatever.
Precisely, yes. C, wait, C transpose D? Can't remember. C transpose D, yeah, I guess, yeah.
So then the end question is that if we have this Boolean array that we had before, so if we do a Boolean operation on it, it will treat it as Boolean.
It will still, yeah.
So
Yeah.
we don't need to care.
You don't need what?
I don't need to really look at what data type it is.
No, you don't have to, precisely. Yes.
Can I apply an arbitrary function like sinus or something like that to a matrix element-wise?
It depends on the definition of the function. I don't know if each function is defined.
So the function has to support it, but I cannot write dot function names something that will apply to
No. It depends on the definition of the function. So sine, for some reason, they made it so that you can apply it, you can map it. But this depends on the actual implementation of on the actual definition of the function. Yeah.
What if they don't have the same size?
Which size?
For example,
It gives you an error.
4 by 1 vector and a 2 by 1 vector.
Yeah, you cannot do that.
But it works for Boolean operation.
No, it doesn't work.
Wait, can you use Boolean operations on 2 matrices?
Plus 1, 2. I promise that doesn't work.
C greater than D. Can you do that? Element-wise?
Yes, you can do that. As long as they have the same dimension. You guys can play with this a lot, as long as you want. Let me do something. I want to move on and show you how to do some assignments. So, we have seen, no, I don't think we have seen. Have you guys any idea what this is? Sorry? So, why so silent? For 4, it's a 3 by 6 matrix. For 4 should not be defined. It's out of bounds. Can I do this? It's a yes. Yes, I can easily do this. This is almost as bad as going out of bounds in C. You're actually defining a new object that is larger than what you had before, and you don't realize. So pay super attention to this, okay? It's a perfectly valid assignment, and the whole matrix is extended so that your assignment makes sense. Be very careful. Now look at this.
So what if you use 6? So that would be 1 here.
What?
If you would use 6 now, 4 and 6.
4 and
So we have
yeah, you would write something here. 4 and 6, that's what you would have. 6 and 4, you would extend it up to a 6 by 6 matrix. What is this? So I killed off a whole row. Some of you might be a little disturbed because this object here, it's actually a 0 by 0 object, and it's not a 0 by 6 object. That would be actually more semantically correct. But actually MATLAB accepts this exception. But you can also do the following. So now the third row of C will become okay. What is going to happen here now? I didn't hear. Well, this for sure will terminate. I'm asking him to go from 1 to -1 in steps of 1, so it shouldn't even start. So what's going to happen? Oh. No, 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 no. I don't want it to march towards -1. I want it not to start at all. You like this better? What?
It will do the first iteration of it, right?
Maybe.
If you take the first row of D and attach it under C.
Under? Why under?
No, the third row of C will
Okay.
become the first row of the first.
Okay, I like the thinking. It didn't work. Why not? This should actually be. Oh, wait. Okay, what I was trying to do was to extract a 0 row from here, an empty row, and attach it over there, which would mean to zero out the third row of C. So why is this not working? That's the problem, that I'm not accessing it. So maybe like this? No?
No, go from 1 to start from 1. Yeah.
So this accesses that. And no. How do I do that?
Use empty square brackets.
Ah, that's a good idea. So let's see. Steps of 3 to 2. No.
No, empty square brackets instead of the 1, 3, 2 stuff.
Thank you. So all of that was to show you. Yeah, but it's cheating. I mean, I'm starting off with an empty row, and I'm attaching it onto the third row. I'm actually overwriting it, the third row of C, and so I am. Ouch.
How can you one to one in steps of 1?
Okay, I'll get back to this later. It doesn't matter. The important thing is that you can write out of bounds. You cannot read out of bounds, which is better than C, but you can write out of bounds. What's the time? Okay.
So he had done 1 to 1 steps of 0.
Okay, something else that I wanted to show you is this. We have talked about nuns, right? And I told you that a nun, not a number, is something perfectly valid. So now we have a not a number in our matrix. But we can have an infinity as well. Okay? And now let's do some math. So we have plenty of zeros, we have infinities, not the numbers. We can do some crazy math. Let's divide these objects entry by entry. I am computing 1 over the reciprocal. You see that infinity now becomes a 0. All the zeros become infinity. Not a number stays not a number, and everything else you actually computed the reciprocal. So I taught you this last week. Not a number is a concrete quantity, infinity is a concrete quantity, and so on. You can actually do math with it. Very good. Okay, I guess I can finish with now that you have seen that we can write outside the bounds, maybe you can think that, remember what A is, what B is, maybe you can think that you can do this, which would be just a square and a vector with just zeros. Well, actually that doesn't work. So the square braces really only work for matrix objects. And anyway, I recommend you guys do not use this writing outside of the boundaries to define anything. Always start with something like 0 of the right size and then fill it appropriately. So you always keep track of the dimension of the objects. And then let's do some matrix multiplication. So A is 1, 2, 3, 4. Now B is, what is it? 1 minus 1, 1, 1. Okay. Can I do this? Okay. Is it going to be the same as this? What about this? Can I do that? Is it going to be the same as, no? What about this? Okay, so in the end, what are we going to get if I press enter? What's going to be the output?
2 by 8.
What? 2 by 8, okay, and what will I see in this 2 by 8 object?
The results of this.
I will see a 2 by 2 matrix, a 2 by 2 matrix, a 2 by 2 matrix, and the same one. Yeah? So let's see if... so it is a 2 by 8, 2 by 2, 2 by 2, and the same twice. So you see, matrix product is non-commutative, so these two guys are different. This is not a matrix product. This is called Hadamard product, pointwise multiplication, and of course that is commutative. Okay. I guess we can stop here. You have questions? Okay, you don't have any way of programming in Matlab yet, so next time we do if statements, for, while loops, assignments. Well, we have seen assignments already. And function definitions. Oh, wait, next time is Thursday. I think that on Thursday we'll also show you some elegant solutions, maybe how I would have solved the homework. So probably this Matlab will continue next week as well. Okay, see you guys.